Configure and verify EIGRP in the world of IPv6. Are you ready? Let's begin. Our objective for you and I in this nugget is simple. It's to take EIGRP and add it as a routing protocol to a Cisco network. We're going to take a look at the exact configurations to pull that off and also how to verify it. So here's our topology. I'm going to be using this major network as we discuss, and it's 2001 DB86783X. Now, X is not a hexadecimal character. It's too big. X goes all the way through F and it stops. That X represents these subnets. So when it says 367 here, that is the 367 subnet in the IPv6 space. So here's the 245 subnet, the 123 subnet, and a few others along the path. Also, to save ourselves a little bit of time, I've already configured EIGRP on R2, R4, R5, R6, half of R7, and R3. All we're going to do is configure it on R1 because guess what? Once we have identified the three basic things to do to enable EIGRP, it's simply wash, rinse, and repeat to apply that same type of configuration to the other devices. So without further ado, let's go to R1 and identify the three basic things we need to do to bring up EIGRP. The first thing we need to do, which is a showstopper for many people, is to configure an EIGRP router ID on the router. See, in IP version 4, we never had to worry about that, but with IP version 6, we do. So to do that, we go into router configuration mode. So I said IPv6 router EIGRP, autonomous system number 1, and all the routers have to join that same autonomous system number, and I'm going to specify EIGRP space router-ID. I'm going to give R1 the router ID of 1.1.1.1. Now everybody needs a router ID and they all need to be unique. So we don't want to duplicate that on any other device. Now although that looks like, to you and me, it looks like an IPv4 address because the dotted decimal look and feel, it's really just a representation of a 32-bit number, and we're assigning this one to the router ID for EIGRP on R1. The next challenge that stops a lot of people with EIGRP on IP version 6 is the fact that the routing process is shut down by default. So we have to actually bring it up with a no shutdown command. In IPv4, we configure the routing protocol, put some network statements in, and we're up. Well, unfortunately, we have to do the no shutdown command or we will not be up. Another big difference, and the third item that we need to do to get this going. Number 1, we did a router ID. Number 2, we did a no shutdown to bring the router process up. And the third thing that we need to do is put interfaces into EIGRP. See, R1 right here has some beautiful interfaces. It's got a loopback interface. It's got gig 10. But unlike IP version 4, we don't use network statements to include those interfaces. Instead, we go right into interface configuration mode and we tell the interface, hey buddy, you're invited to the party called EIGRP Autonomous System number 1. So let's do that next. Again, the network statements that we used with things like RIP and OSPF and EIGRP in IPv6, all those are implemented in interface configuration mode instead of using network statements in router configuration mode. So that's a significant difference. So let's just put gig 10. We'll go to interface gig 10 and say, dear Mr. Interface gig 10, congratulations, you get to participate in IPv6 EIGRP Autonomous System number 1. And look how happy he is. He's already gotten some feedback. It says, boom, I've gotten some adjacencies already from FE80::2 and FE80::3. And that's a good point to remember too, that link local addresses are what are used between routers when they exchange route updates. So R1 is communicating with R2, that's FE80::2, and R3 over here to the right is FE80::3. And R1 himself has a link local address of FE80::1. So the three basic steps are set the router ID, bring it out of a shutdown state, and add interfaces into EIGRP. And that's the basic steps to get it up and running. There are several steps to verify that it's worked. We can just do a show of the IPv6 routing table, and if all the routes show up, that would definitely be one way of doing it. But we can also take intermediate steps as well. In case of troubleshooting, maybe we want to ask the router, hey, which interfaces are participating inside of EIGRP? And to ask it that, you simply do a show IPv6 EIGRP interfaces, and it will tell you exactly which interfaces are participating in EIGRP. And the answer on R1 should be just one, gig 1/0, and it is. That's great news. The next logical question that we could ask this device is, who are your neighbors? So we simply ask him with the relevant show command. And a lot of these are very, very similar to the world of IPv4, except now we're just putting in the keyword IPv6 to let the router know we're interested in IPv6 EIGRP neighbors as opposed to IP version 4. So show IPv6 EIGRP neighbors should show us two neighbors. They should be R2 and R3, and it's going to represent their link local addresses. So that's R3 right there, and that's R2, and they're good to go. So we have the hold down timer of 15 seconds. Updates, hello intervals are every 5 seconds. If we haven't heard from a neighbor in 15 seconds, we're going to consider that neighbor having a problem, and we're going to disassociate any routes we learned from that neighbor from the topology database, which is going to reflect a reduction of those routes inside of our routing table. Now, every router should have a full route to everything if it's all working. Let's go over to R4 for a moment. And on R4, let's just take a look at the routing table. Do a show IPv6 route, and we'll say just show us the ones from EIGRP, and that will thin it down a little bit. And there's a whole boatload of routes which represent all the routes that we've learned via EIGRP. So this bottom one right here, the 8888 network, represents R8, and it's got a loopback interface on that router. It's showing as an external route because there's some really sweet redistribution going in between this routing protocol over here, which is RIP, next generation, and EIGRP. And we're also redistributing EIGRP into RIP. So that's why we have that connectivity. Let's go ahead and verify we can ping that destination. Let's do a ping. I'm going to do a copy paste here. Grab that address, paste it in, and we'll say 8. That happens to be the loopback interface on R8. So from R4, what I think is going to happen, it's going to route through R2, and it's going to go over here to R3, because that's just one network right there, and then down to R7, and down here, and then the return path is going to go something like that, the other direction. So that's the theory. Let's see if we can get a ping out of this working. And it does. Now, there's no ARP anymore. We don't use ARP in IPv6. We use neighbor discovery. So if the first one had timed out, it would be due to neighbor discovery, not due to ARP. And that takes a little while to get used to that as well. Let's also verify a trace to that same address. Let's do a trace to same address. Paste that back in. :8, and that can show us the individual hops. The hops we would expect to see, or the routers in the path, would be from R4's perspective. We have R2 should be the first, and then actually we're not going through R1. It would go right here to R3. That'd be our second, and then go to R7 would be our third, and we're directly connected there. So it should be 4 routers to go through to get to that destination. R2, R3, R7, and then finally R8. We can verify that with this trace. We'll simply run it. And that says, drum roll please, R2, R3, R7, R8. Perfect. Took the exact path that we thought it would as it went through the network. A great way to verify full connectivity and the path that's being taken through the network. In this MicroNugget, we've had the opportunity to take a look at the 3 basic things to get EIGRP up and working with IPv6. Do a no shutdown, the router ID, and invite the interfaces to the party. We also verified our configuration by taking a look at the neighborships, the routing table, and a trace and a ping to verify connectivity. I've had a great time. I hope this has been informative for you, and I'd like to thank you for viewing.